No Atom, Grade 5, Unit 1, Matter in Motion, page 11. Matter in Space. From its position above Earth, the Hubble Space Telescope makes observations of Earth, the Sun, and distant stars. Earth, the Sun, and stars are examples of matter. Matter is everything that has mass and takes up space. All matter is made up of tiny parts that are too small to be seen. These parts are called atoms. An atom is the smallest piece of matter that has the properties of an element. An element is a substance entirely made up of one kind of atom. There are 118 different kinds of elements. All matter is made up of combinations of the 118 elements. Both non-living things and living things are made up of atoms. Even though atoms make up both living and non-living things, atoms are not alive. Atoms are so tiny that we cannot see them. Just one grain of sand is made up of many millions of atoms. Think about a grapefruit. If each atom in the grapefruit were the size of a blueberry, the grapefruit would have to be the size of Earth. There are so many atoms in just one grapefruit that they are impossible to count. Imagine having to fill up the entire planet with blueberries. That's about how many atoms are in one grapefruit. Atoms themselves are made up of smaller particles called protons, neutrons, and electrons. These smaller particles are much smaller than the atom itself. Because atoms are so tiny, scientists use scale to better understand the size of an atom, its smaller parts, and how it relates to everyday substances. Scale is the size, extent, or importance, magnitude, of something relative to something else. For example, the protons and neutrons group together in the atom's core called the nucleus. If the atom is the size of a blueberry and you open the blueberry up, the nucleus would be too small to see. If you were to make the blueberry the size of a football field, you would just be able to see the nucleus. It would be the size of a small marble. The nucleus holds all of the atom's protons and neutrons. Most of the atom is filled with empty space. The electrons are much smaller than the protons and the neutrons. They are in constant motion around the nucleus. However, there are huge amounts of space between each of the electrons and between the electrons and the nucleus. Forming matter. All of the matter that exists, including stars, planets, and all of the other stuff in the universe, is made up of combinations of the 118 different kinds of elements. There are so many different kinds of matter because atoms are like Lego blocks. They can fit together with other atoms to form bigger pieces of matter. Whenever two or more atoms join together, they create a molecule. Molecules are formed as a result of a chemical reaction between two or more atoms. In a chemical reaction, the atoms of the original substances are rearranged to form new substances that have different properties from the original substances. There are a couple of clues to look for to determine whether a chemical reaction has occurred. For example, a change in color or odor can be a sign that a chemical reaction has taken place. Also, if a gas forms when two different substances are mixed together, a chemical reaction has occurred. Caption. Rust is the result of a chemical reaction. It forms when the element iron combines with oxygen. Conserving matter. Chemical reactions occur when two or more atoms interact. The effect of this interaction is that the atoms are rearranged to form new molecules. However, the total number of atoms does not change in a chemical reaction. The mass of any one element at the beginning of a reaction will equal the mass of that same element at the end of the reaction. This is called the conservation of matter. It states that atoms are never created or destroyed during a chemical reaction. They are rearranged to form new substances. For scientists to measure that matter has been conserved, they must conduct the chemical reaction in a closed system. In a closed system, matter is prevented from being added or removed from the system. In contrast, in an open system, Some of the mass is transferred to the environment, which is impossible to measure. Matter has different properties depending on the number and kind of atoms that make it up. A property is an observable or measurable characteristic of matter. Properties help scientists classify and describe different kinds of matter. Properties include texture, flexibility, color, mass, volume, temperature, and odor. For example, scientists can use color to describe an object. Color is an observable property. From space, Earth is green and brown from the land, blue from the oceans, and white from the ice caps and clouds. Caption: Earth's colors are a result of the matter that makes it up. Properties can also be measurable. Measurements are an important part of science. Scientists use the metric system, which communicates measurements of mass and distance in units such as grams and meters. Mass is an example of a measurable property. Mass is a measure of the amount of matter that makes up an object. It increases as the number and size of atoms increase in an object. It is measured in grams. Whether or not a substance is a solid, liquid, or gas is another property of matter. This is called state of matter. Earth's atmosphere is made up of a mixture of gases. Gases are different from solids or liquids because of the amount of heat present. The atoms in gases are far apart and move with a lot of energy. As a result, a gas takes the shape of whatever it is in. It will spread out to fill all of the space it is in, no matter how big the space is. In liquids, there is less available heat than in gases. The atoms in a liquid are close together but can slide past one another. This is why liquids flow, taking the shape of their container. The water in oceans is an example of liquid water. Solids have the least amount of heat. They do not have enough energy to move past one another. As a result, solids hold their shape because the atoms that make them up are packed tightly together. They hold their own shape until something changes them by force. Earth's land is an example of a solid. Remember that cause and effect describes the relationship between events or things where one thing is the result of the other. For example, when the right amount of heat is added or taken away, it causes a substance to change state. When a substance changes from one state to another, it is a physical change. In a physical change, the atoms and molecules that make up the substance do not change. For example, if you leave an ice cream cone outside on a hot summer day, it will melt. The solid ice cream will gain heat, causing it to turn into a liquid. However, the ice cream will not change its chemical structure. It will still have the same properties. It can also turn back into a solid when enough heat is removed. Caption: Melting ice cream is a physical change. Identifying properties of matter. Headings: Property, what is it, observable or measurable. Color, how matter reflects or absorbs light. Examples: red, yellow, blue. Observable, qualitative. Mass, a measure of the amount of matter that makes up an object. Measurable in grams or kilograms with a scale. Quantitative. Shape, the form of an object. Example: circle, square, rectangle. Observable, qualitative. State of matter, the different forms of matter depending on the amount of heat present. Solid, liquid, or gas. Observable, qualitative. Temperature, a measure of how fast molecules are moving. Measurable in degrees Celsius with a thermometer. Quantitative. Texture, the feel of a substance. Rough, smooth, soft, hard. Observable, qualitative. Volume, a measure of how much space an object or substance takes up. Measurable in cubic meters for solids with a ruler, liters, or milliliters for liquids. Quantitative. Qualitative properties are those that can be observed and described. quantitative properties are those that can be measured.